So why do we want to model parking? And parking, it's one of the main ingredients if you want to really manage travel demand in a city. If we look at current models for parking, we find is that many of the current models, they are aggregated in terms of both time and space. And often the individual decisions, they are either missing totally or limited. And the integration between the transport simulation and parking is also missing, and this is very important. The framework we are using is called MedSim, an agent-based travel demand simulation framework. The simulation, this is actually what I have shown you before in the video. It is the first step where you actually perform a full day simulation, like people in the morning, they're waking up, they're going, perhaps taking a bus to go somewhere to work or something like that. So as this happens, you have interactions between these agents, for example, in the traffic, and you can possibly get delays. So after this simulation, you actually score your the simulation result. So if you have a lower travel time, or you can perform longer activities, you get better score. And the goal is kind of to maximize the score of your day. And in order to do this, you have a replanning step. This means you can adopt your plan. For example, you can change your travel mode, you can change your route, you can change the departure time, or in my case, probably your parking. And with this, you try to improve your score. In the end, what we're kind of trying to get to is a Nash equilibrium, meaning that no agent can unilaterally improve its score. So the parking choice model works as follows. So first of all, you just discard things which are too far away. Then what you do is you kind of remove the occupied parkings. You remove the parkings which this person cannot use, for example, private parkings of a certain kind. And then what you do is you use a utility function to assign a score to each of the remaining parkings. When we get this parking score, what we do with it is we add it to the overall utility of the plan. And this is actually the place where you integrate the different choices of the agent. Let's say you would like to reduce peak traffic. You could look at the peak demand. You can find out where are these agents coming from or going to, which travel during peak hours on these links. And if some of these activities are happening in the city of Zurich, you can kind of form clusters and start reducing the parking supply in those areas. The traffic on these highest volume links, it goes down. Thank you.